Hey y'all, we're going to be talking about how magnetic fields are created by moving charges today. All right, so remember that moving charges per time is called a current. So currents, even just electrons or protons or stuff that were moving through the air, can actually have magnetic fields associated with them. All right, so when a current is flowing in a wire, a magnetic field is created. So if this is a wire and the current's going through that wire, then there's a magnetic field around it. And this magnetic field is perpendicular to the flow of charge. Okay, so basically, if the flow is moving this way, the magnetic field is encircling it like this, so it is perpendicular. It's a circle. All right, so the electric field and the magnetic field are perpendicular to one another. All right, so this is going to lead us to the first of a couple of different right-hand rules that we're going to use. So you're going to have to use your right hand. All right, remember you're looking at a mirror image of me, so it'll look like my left hand, but it's my right hand. And it's used to determine the direction of the magnetic field. Okay, so the first thing you're going to do is you're going to point your thumb in the direction. Here, let me move this down a little bit. I still want you to be able to see this. So you're going to point your thumb in the direction of the current. So if my wire is pointing upwards and the current is going upwards, you'd put your thumb upwards. If the current was going downwards, you'd put your thumb downwards. If it was going this way, you'd point your thumb in the direction of that current. Okay, and then your fingers, when you do this, kind of naturally curl, right? So your fingers are going to curl in the direction that the magnetic field acts. So again, if the current's acting up, you put your thumb up, and your fingers curl in this direction. So the magnetic field would act around a circle in this direction. So if I look down on it, it would look like it was going kind of in a counterclockwise direction. If the current was going downwards, your thumb would go down, and the current would be in the opposite direction, more of a clockwise direction. If your current was traveling in this direction, you put your thumb in that direction, and then your fingers wrap like this, so the circle would behave like this around there. Okay, so this is a three-dimensional, we have to think in 3 dimensions here, and we're going to have to draw a little bit in 3 dimensions, right? But if you've ever seen my drawings, I'm not very good. So we find ways to draw in 2 dimensions so we can represent 3. Okay, and so that's what we're going to do. So basically, we'll use our page. Okay, so when we look at a page, like if I have a piece of paper here, our directions are going to be towards the top of the page, towards the bottom of the page, left, right, and then it's going to be in and out, or sometimes we'll say it's up and down. Okay, into the page would be this way, out of the page would be this way, top of the page would be this way, bottom of the page would be this way, and so on. Okay, to represent something that's into the page, you just draw a circle with an X in it, right? To indicate a vector or a direction that's out of the page, you draw a circle with a dot inside of it. The way I remember it is I think of like either a dart or an arrow, like from the game of darts or when you shoot an arrow. If the arrow was going into the page, it's going to be moving away from you, right? It's going to be moving away from you. And the last thing you see are the little feathers at the end that make an X, right? And then if the arrow is coming out of the page at you, again, if this is my page, if the arrow is coming out of the page, the first thing you see is the tip, and that's what we see coming at us, is the tip. That's how I remember it. You can just remember how you want, but that's the easiest way for me. Right, so we now have our 3 dimensions. We're going to have top and bottom of the page, left and right of the page, into the page, out of the page. All right, so basically there is the magnetic field for these current carrying wires. Okay, so in this particular case, the current here, this is our I, right? This is our current, and circle with a dot means it's coming out of the page. So we would represent, if you want to take a pen and kind of show it going up out of the page, means your thumb is going to be pointing out of the page, and my fingers are going to wrap this way. And if I look down on it, we see that that's a counterclockwise. So we would draw a circle around here. I'll do it another color. And then we would draw an arrow to indicate that it's going counterclockwise. That's all it is. If I have it going into the page, then my thumb points down. It's also going to be a circle around this way, but it's going to be in a clockwise direction. And that's the only difference between those two. All right, now this one's a little bit trickier because now my current is acting towards the right-hand side of my page. So it'd be pointing like this. So my thumb would point to the right. Okay, your right. Okay, and then when your thumb will come out here. And notice that on the top side, this side, the top side of above the pen, your fingers are coming out of the page. So you'd represent that part of the current by being a circle with a dot. Right? And then if I complete it around, it goes around. And then on the other side, notice that the magnetic field is going into the page because it comes out, goes in, comes out, goes in, around and around. So this would be an X over here. And with it going in the opposite direction, it would be the exact opposite. So now, if my current's moving this way, my thumb would point in this direction. My fingers would go into the page up here and out of the page down here. All right. So I attached another sheet with a bunch of other practices on it. Just practice them and see what you can do with them. On tomorrow's a digital day. I'm going to have you all start on an online lab that talks about electromagnets. But on Wednesday, we're going to come together as a group and we're going to talk about several of these right-hand rules just to make sure that you're comfortable with them. Right. And at this point, y'all have a great day.